So systems of equations, you've done linear equation systems, right? So if we looked at linear systems again, what are the possible intersection points? And we could have one intersection, right?
Mm-hmm.
What else?
One, two.
Can I have two?
It's a
No, just linear.
Oh.
no.
Infinite.
You could do infinite, right? Same line.
One infinite or zero.
And then we could also do none, parallel lines, right?
Yes.
Okay, same kind of thinking applies here. If we're in degree 2. Is there a spot where I could have no intersections? Can you think of something? No solutions is what we would formally call it. Caleb, this is your one question.
C. So it was like the lines are parallel, so they have the same slope, but different.
Okay, we're in degree 2 now. We need circles, parabolas, ellipses, or hyperbolas.
So
Can you
like,
think of a situation where that would occur?
like 2 degrees. Like there's 2 degrees in a circle.
No, degree 2 is equations like y equals x squared. Degree 2 polynomials.
Oh.
Or x squared plus y squared equals 9, a circle. See the degree 2. So so in linear equations we had no solutions
Yeah.
with parallel lines. Is there a situation you can think of with 2 of those types where there would be no solutions?
So if you got like 2 parabolas, where one starts at like positive 2 and the other starts at -2, and they have the same arc. That work?
You mean like this?
Yeah.
Yeah, if they never intersect. You think of anything else?
Or one is facing downwards.
Okay, that would work. You could do this.
How do you play it?
Two parabolas that don't intersect. You could do a circle and a circle.
X cubed.
We're second degree. We don't want to get into that mess. You could do a parabola with a circle in it. And you could add a couple of ellipses and make your happy face.
Yeah. I can't see it now.
Yeah. Okay, aside from being funny and stupid, how about one intersection or one solution? And like circle, ellipse, right? Or you could do
Like the parabolas, but like they touch on. They have the same vertex. One's like-
parabolas.
No, that would be two. Oh, yeah, that.
But
Okay.
like one's opening up and one's
Right,
opening
so you get the
up.
idea, right?
Yeah.
2 shapes that touch in one spot. Can we do 2?
Yes.
Ah.
It's the most common.
Yes.
No.
Yep.
A circle, right?
Circle.
That's a one.
Yeah.
Oh, okay. That was one of those entire.
Okay, here. Can you do 3?
Probably. Not. Wait.
Probably not. Probably.
We can do 4.
Yeah.
Or if you have more than one. Or than one.
Circle and what? This would be 2 shapes.
Yeah.
Circle and an ellipse.
3 circles. We don't do 3 circles. That gets kind of messy.
A circle and an ellipse.
Well, if you did 3 circles, you could have 3. A circle and an ellipse.
That'd be 4 for
Like a big circle. And then the ellipse again.
Yeah, like that.
3.
Whoa.
Whoa.
Or
You got a circle.
a circle,
Like
and then the
parabola.
parabola, but it goes up.
Like a skinnier, and it just sits at the bottom.
Oh,
Like it goes through, and then it's
Yeah,
out.
yeah.
okay. Good. Yeah, you're thinking now. We could do a hyperbola too, right? Where hyperbola touches once and twice. Okay. You get the idea, right? Could you do 4?
Yeah.
I mean,
Yeah.
Yeah.
Saturn.
woo, we're doing astronomy now. Can you do 5?
That I can.
You can't do 5 because there's no room on the paper, right?
Yeah, that's right.
Because why?
Only with two shapes?
Yeah, only 2.
Well, you like
I'm
angle?
pretty sure you can't.
I'll take the common.
Can you do anything else? Can this happen?
Yeah.
Yeah. No, you cannot.
Yeah, absolutely. A parabola on a parabola.
Yeah, you get the same curve. You put a circle and
What's on
then
the list? Get that line.
same circle, right?
Yeah.
Okay. All right, so those are kind of what we're looking at. That's what we have in front of us. All right. Here is a system of second-degree equations. And what we got here? We can include lines in here if we want. So solve the system. Okay. What methods do you think we could employ? You had your chance. Thinking through what we already know about linear systems. He says substitution works, right? How would you execute?
Figuring out why for the linear line.
So make this negative 2x minus 1 equals y,
Yes.
and then subbing it in for y. Right, so we end up with that. So that's substitution. How do I solve that?
Oh, why do you think why now?
It equals 25.
You
Don't. I'm in a bad mood today, don't mess with me.
Yeah, I was there.
Shut up. You were the one that didn't get out of bed this morning on time.
No, I did get it. I think we did.
How do I solve that equation? What do I do with that mess? Hey, sing it, Kellen. No, never mind, don't sing it.
Oh, do you not?
So you're in choir, right?
Okay, we are not looking for a boy band impersonation here. All right.
I'm always
Yeah.
looking for a boy band.
Pretty sure.
In my life.
Correct me if I'm wrong.
You're wrong.
I'm pretty sure I'm right, but educate me.
Oh, that's
Not gonna happen. All right, so you get most of these come down to a quadratic. We just talked about it from the homework. How can you solve a quadratic?
You can complete square, you can factor.
Put in quadratic.
Okay, that's 3. Graph it. 4. Okay, so what do you want to do? Can you factor that?
Yeah. Yeah.
You could certainly make it easier. How can we make that easier? You've had your chance. Somebody said it.
Wait, add 1 each side, and then divide.
Is there a
by
common
4.
factor here? Divide by 4, right?
Yes. 2x squared plus x. There we go.
Now it's easier to factor if it's possible.
Yeah, it is.
Is it possible?
Yeah.
So we get 2x and x. And that has to be -6, right? So I would put that.
But that wouldn't give you a positive x.
It does. Remember, you got to consider this in there now. The outsides are 4x, and the insides are -3x. Does that make 1x?
Oh, that's it.
Yeah.
Yeah. So that was just a plug and chug on my part. Do you remember how to do the box Punnett square methods?
No. Oh.
Okay, so what are my zeros here? -2 and 3/2? Okay. Stop it! Okay, so I found my x values, correct? How do I find y values? Yeah, plug these each into the easiest one. All right. So if x is 3/2, -1 equals 2 times 3/2 plus y. That'd be even easier if you use that one, to be honest with you. So 2 is y?
Wait a minute.
Did I do that wrong? Yep, I did. Gotta keep an eye on that. That is 3. Subtract 3, you get -4. Right. Yeah, you with me?
Yeah.
You're awful quiet. That worries me. I like it, but it worries me. What?
Oh, it's not 2x? Oh.
Equation. Substitute x in. So my point there would be 3/2, -4, right? Okay, what's the other one? Three. Thank you for leaving. Look at me like that. I was glad you were gone this morning.
Wow. Roasted.
I'll give him props. He has been lifting at 5:30 in the morning with us, but he ditched. That's why I'm giving him a hard
Sprained my
time.
back yesterday and
If you'd have seen him deadlift yesterday, it would have hurt your back too.
If you do a lift process, it doesn't happen.
Caleb, were you actually?
Pretty much.
Montana
All right.
said you were.
Yeah, Montaigne made him look bad. That's what was happening. All right, so we have 2 points of intersection. Does that make sense? That, do you know what shape that is?
It's a square.
That's a T.
Looks to me like
It's an ellipse or a circle?
Square.
Circle, square. It's not a square. I just gave you 2 options. Multiple choice.
It's
I
a
do believe
triangle.
it's a circle.
It's an ellipse. Why is it an ellipse and not a circle?
that way.
Does that equal 1?
No.
Okay, so, but in a circle, it has to be x squared plus y squared. There can't be any multiples. That right there tells me it's an ellipse.
No.
Whoa.
So what you really have is an ellipse. You have to reduce that number. Right, 6.25, correct? So b is the square root of 6.25. A is 5. And you can graph that ellipse, right? Is it vertical or horizontal? It's a vertical ellipse. So you got an ellipse like this centered at 0, 0. And you have a line like that. So we've just found two intersections.
Why do you need
What?
I have questions.
All right, how about it?
So right there.
Right where?
And you like put the equation back in there, and then you plug in X, right?
X,
And then that's a Y. Okay. And then
Y.
negative 4 equals Y.
So this should be 3.
Yep.
Subtract 3.
Okay.
It's not too large, just one. Just the way you want it.
Y'all are very picky.
This is your handwriting.
Your handwriting sucks.
Why not? But, like, I can't do it. This is your
And you're
handwriting.
picking on me? I'm just kidding. Being kind of mean today, huh?
Huh?
A little bit.
It's pie day and I don't want pie. I'm very unhappy.
Wait, why is it Friday?
3/14. It is March 14th. 3/14. 3.14.
I thought they were drinking sugar, but
No, it's the 14th for sure.
And you have-
Kellen, you had a question
Do.
before I shut this party down?
Where's that linear line that deals with the party?
What?
Where'd you get that line?
Right there?
Negative 1.
the linear equation.
Oh.
Right, I made it y equals, so I have an intercept of -1 and a slope of -2.
Oh.
So this is one possibility. You can algebra it, or you can graph it. Just remember, graphing is not as accurate. And frankly, with second degree equations, graphing is a lot more work than linear equations. Okay, so algebra is faster. Okay. Any other questions? There are no stupid questions.
Can we go buy some pie?
Only stupid people. Tomorrow I will show you another one that's harder. All right.
Ask it.
No.
Kellen,
He has a question for you.
are you about to show your true colors?
No. It's fun.
He has a question for you.
Shoot, man, pull the trigger.
No, it's okay.
For Kellen, ask it.
I'd rather not. You can do it.
I'll do it.
Do it.
Kellen wanted to ask where babies come
I dare you to ask.
I'm going to shut the video down and I will answer that question.
Yeah.
And I will embarrass the heck out of you.
We had to watch that.
from.
You watched that video?
Yeah, it was rough.
I forgot that. Like not.
Uh,
And it just like took me by surprise.